Hello everyone, it's me, and welcome to lesson 4 of the spherical tank. This lesson we're going to create a handrail around the top platform. It's gonna be like a pole. There's gonna be 12 poles and a handrail that connects the poles together. So let's get started. First, let's create top platform handrail. So that we're gonna have two def functions. One is this, and I'm gonna make the other one in a bit. And we're gonna have put the final result, the find function. We're gonna use it inside the create take def function. So it's gonna be easier to use. So create top platform handrail, top platform Z, platform radius, platform thickness, sphere radius, number of posts is equal to 12. So this define function is basically just building everything. We're gonna have another one which is gonna help it builds everything. Let's create a comment so we know what it's gonna do. Create a circular handrail around the top platform. Posts are placed evenly along the platform edge and connected by rail segments. So this kind of just gives the idea on what it's gonna look like, even though I already explained it. First, let's get some variables that are gonna be important out of the way. Platform top Z is top platform Z plus platform height. Not platform height, platform thickness. We got the half of that. So the Z coordinate of something is the middle. So the top platform Z is the middle of this. It's the orange dot you see in the middle. This one. Not the big circle, the small one on the platform. But we want the Z of the top of the platform. So to get that, we just have to add half of the thickness, which to get the Z coordinate at the top, which makes sense. So that's going to be an important variable. Another important variable is rail top offset is sphere radius times 0.25, and this is just going to be the height above the platform for the handrail. And I spelled height wrong. Oops. So what this variable is, it's just the it's self-explanatory. It's the height of the platform, which is a quarter of a sphere radius. So if you remember what radius is, it's basically the length from this orange dot here to any part of this circle. Not a circle, a sphere. And we want a quarter of that to be the height above the platform for the handrail. So let's say the handrail is over here. The length from here to here, it's got to be a quarter of the length from this dot to anywhere on this here. Now we're going to create a list post top positions, and I'm going to explain what it does later. It's empty for now, but we're going to fill in some stuff. For I in range. So now we're going to start coding some stuff. It's going to start with this for loop here. Angle is 2 times math dot pi times I divided by number of posts. I'm gonna draw something really quick to explain this line. Okay, so let's look at this. Angle equals math dot pi 2 times math dot pi times I by number of posts. So let's first draw a circle to help us understand this better. That's too low. Here. Now let's draw some lines to split this. Now we're supposed to have 12, but I'm just gonna draw this much, which is 1, 2, 3, 4, 5, 6, 8 lines. Okay. Now time to start explaining. So the distance between each line, I mean there's an angle between these two lines, these two lines, these two lines, these two lines, right? Right. And in Python, when we want to show the angle, that at 360-degree angle, which is a full circle, we write 2 times math pi. So, right, 360-degree angle is equal to 2 times pi in Python. So that's 2 times math pi. Now then we're going to skip to number of posts, which is 12, but we drew 8. So we divide that 360, or 2 times math pi, by the number of posts to get the angle of each part, which is supposed to be the same, but when I drew it, it's not the same length, not the same angle. Okay, now what about this times I? Well, it's to get the, if we don't add it, we're gonna have the angle between this and this, 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 etc. But when you add times I, we're gonna get the angle between this and this, this and this. So, yeah, that's what the angle is. Okay. Next, we're gonna have base of post at the platform edge. So we're gonna have the bottom or the base. That we're gonna find that location here. Platform radius times math, the cosine angle, and if you remember from another lesson, if you draw, let's say we have axes, this is the x-axis, this is the y-axis, and like this is the origin, and I have a line, we draw two perpendicular lines from this point to the x and y axis. Okay, and the equation for the x-axis is... Wait, let's first say what cosine theta is. By the way, theta is the angle over here. Cosine theta is equal to A divided by C, right? It's A divided by C. And in our code, we don't have, but we want to find A, right? We want to find A. And I should define A, B, and C. Wait, I'm sorry. So A is the length from here to here. Right. C is the length from here to here. Okay, I'm sorry for not defining those earlier. Okay. So we want to find A. And cosine theta is A divided by C. And if you see here, we define angle. We can see that's cosine. Not cosine, it's in this equation, it's the theta is angle. So that's theta, and so now we want to find A. So, but we have theta, we have C. So the way to find A is just multiply C on both sides. A divided by C times C is A. So C times cosine theta is equal to A. And that's what we're doing here. Platform radius is the length from here to here, which is also the and the end of this radius is the coordinates we want to find. So cosine the angle times C, the platform radius, will get us A, the length from here to here, which is also the x-coordinate of this point here. So that's the x-coordinate. Now we write platform radius for the y-axis. That's what we're finding, times math dot sine angle. This is the y-axis, which is similar, but this cosine is replaced with the sine. So let's explain that. So let's define this line as B. Okay. So B divided by C is equal to sine theta. Alright, and we want to find the length of B because that's the y. So we just have to multiply C by both sides like last time. So yeah. Which explains the sign for the math. The sign, no, the sign for the y coordinate. And then the z is platform top z, the variable we just defined earlier. So the base is just the z of the base of the pillar, It's just right over here. Now for the top. The top is, it's the same thing for the X and Y. Wait. Never mind. It's the same for the X and Y. The Z is a bit different because, I mean, the length is vertical. The length is vertical, so the X and Y will be the same. But since it's the top as a vertical thing, so the Z is gonna be different. Which, it's just the base is Z, but we add right out top offset. Which, if you remember when I explained it, the length from one place to the, from this to the top of the post. Now we actually go out of this define function. We're gonna come back to this later because the next line we're going to need another define function. So def create cylinder between points P1, P2, radius 0.05, name is segment. Create a cylinder connecting two 3D points. So let's look at what we have so far. So judging by the name, we're going to create the handrail in between the points, which I'm going to draw it. So if we remove this and let's draw something else. So let's say we have these posts I marked. We're going to the handrail. It's just gonna be a straight line connecting everything. That's what we're gonna be making. What in this function. So first we have to define the midpoint. P1. Oh yeah, and the P's are the points. So, and when you see the little zeros and ones, it's the zeros mean the X, the ones mean the Y, and the twos means the Z coordinates. Times 0.5. And make sure you parentheses the addition, because it's because What's that? Oh yeah, because of linear operations, you don't want to have half of the second part added to the first part. You want them both added, and then you want them both added and halved. Okay. Now let's have a variable. It's going to be called a dist. Sort for distance. And it's going to be the distance between P1 and P2. Now let's add the cylinder. Cylinder add. Radius is radius. Depth is dist. Because when we generate it, at first it's going to be vertical, and then we're going to rotate it, so depth. So right now it's still vertical, so that's why the height or the distance is depth. Location is mid. We want the midpoints. CYO is bpy.context.activeObject. So we're giving it a name. In Blender, in Python it's called CYO. In Blender it's the name parameter, which is segment. Alright, now we can rotate it. Which I'm gonna have to draw again. So D is mathutils dot vector. We're making a vector. P2 0 minus P1 0 is the x. P2 1 minus P1 1 is the y, and the z is P2 2 minus P1 2. Alright, I'm gonna draw what we're about to do now. So let's say this is a graph that x and y axes, and we have a length over here. The slope of this length is y2 minus y1 over is y2 minus y1 divided by x2 minus x1, right? Okay. Yes. In our situation, these 2 points are gonna be P1 and P2, which whose coordinates are x2, y2, x1, y1. Right, okay. Now we have this line. It's coming from the origin to this point. But this this point over here, its coordinates are x2, x2 minus x1, y2 minus y1. This line is parallel to this line. Alright, so D is a vector parallel to the P1 to P2 vector here. Okay, that's what D is. Now we have to then put CYL, that rotation mode is quaternion. So that's how we're going to rotate it. It's called a quaternion. Okay, and now, okay, what this does is that it takes the cylinder, rotates it in such a way that the z-axis is parallel to vector D, which is parallel to P1 and P2 vector. That way, we can rotate it. No, don't forget returns, and that way you rotate it so that it's still parallel to this, but it's rotated. Okay, what about the z and y? So z just means to rotate the z coordinate. What about the y? Well, the y isn't really needed, but I'll explain what that does. So you can rotate the z two ways, like this, or like this. What this does is that it just says we want the y on the top, so we want it to be like rotated like this so that the y is facing up, and not like this when y is facing down. Okay, now we can go back here. Here we can continue. So we actually want to stay in the for loop and use the Utah function we made to create cylinder between points P1, P2 radius is sphere radius times 0.01, and I messed up. I was getting ahead of myself. Okay, it's base and top. You would think that it's P1, P2 because we have 2 points with space and top, because we're actually using this to create the cylinder, to create the poles up here. So we have the base P1, the top P2, the radius is 0.01 of the sphere radius, so it's pretty skinny. The name we're going to F top rail post. Post I. Okay. Post top positions dot append top. So we add the top to the post top positions. It's a list of positions. Now we create another for a loop, but this time it's for the handrails and between the posts. So P1 is the post top positions. So the position of the former top, not the former, the top we used. And we have the ith one because it's a for loop and we want to get all of them. Then post top positions I plus 1. So right, we want the next. So I want the next one because 0, 1, 1, 2, 3, 4. You want the P1, with the P2 to be the post after P1, right? But we also modulus number of posts because when this gets to like 11, this can't get to 12. So when you modulus it, it goes back to 1. And normally, if it's like 1 and 2 modulus number of posts is still 2. So if it stays in range P2 and P1, then nothing will change. So yeah, this is a way so that we can actually reset the loop when it gets too big. Now let's use the function P1, P2, radius is sphere radius times 0.008. So it's a bit smaller, it's a bit skinnier than the radius. It's a bit skinnier than the posts, but I'll move that a little bit. And the name we're going to use F string segment I. I'm gonna close the parentheses. Okay, now let's use this in the square tank part. Let's go to the bottom, but before it says return, add handrail around the top platform. And now, top platform handrail, we use the function with that creates everything. Fill in the parameters, and then we're gonna be finished. Now, let's have Python yell at me for my typos. Okay. First typo. Okay, it's over here. I forgot to put the mesh here. Over here. B2, 0, B2, B2. Oh, here. I see. Then post top positions dot append top post top positions. Oh, I made a typo over here. Okay, I fixed all my typos, and now you can see, look, we have a handrail with the poles on top of the platform. So we're done with this lesson, right? Next lesson we're gonna add the stairs and stuff. So that's it for today. Bye.